Hello and welcome to Module CCS10 on Microbial Control and Measurement Methods. This session will discuss clean rooms, cleaning and disinfection, environmental monitoring, test methods, and regulatory expectations. Learning objectives for this session will cover learning about control measures and best practices in clean rooms, getting insights into microbial test methods, and understanding regulatory expectations concerning microbes. Clean rooms are controlled environments designed to minimize microbial contamination. These environments adhere to ISO 14644 standards, which classify clean rooms based on airborne particle concentrations across various size ranges. EU GMP guidelines specifically outline cleanliness requirements for pharmaceutical manufacturing facilities, ensuring stringent microbial control. Design considerations prioritize smooth, easy-to-clean surfaces and materials that minimize the generation and accumulation of particles, thereby reducing microbial risk. Continuous monitoring and validation are essential to ensure the ongoing effectiveness of cleanroom performance in maintaining low levels of contamination. Cleanroom design focuses on maintaining controlled environments to minimize contamination. Depending on room classification, air can be distributed via unidirectional or turbulent airflows. Grade A cleanrooms, isolators, or Grade A biosafety cabinets use unidirectional airflow to minimize particle disturbances by moving air in a single controlled direction. Turbulent airflow, in contrast, is used in less stringently controlled cleanrooms and is used for particle dilution. Many cleanrooms maintain positive pressure environments, ensuring that air flows outwards. This setup prevents contamination from entering the cleanroom, maintaining cleanliness. HEPA filters are integral to cleanroom design, trapping particles as small as 0.3 microns. This includes bacteria, fungi, and other contaminants, ensuring high air quality within the cleanroom. Facilities employ detergents and solvents to effectively remove dirt, oils, and particulate matter from surfaces, ensuring cleanliness. Various disinfectants like alcohols, phenolics, and quaternary ammonium compounds are used to kill or inhibit microbial growth, maintaining sanitary conditions. These activities adhere to strict schedules and protocols to minimize microbial contamination and ensure consistent cleanliness. The combined effort of cleaning and disinfection creates and sustains controlled environments with minimal microbial presence, crucial for sensitive manufacturing processes and research activities. Sporicides are specialized agents used to eliminate bacterial and fungal spores, which pose substantial risk to product integrity and safety. Sporicides are designed specifically to target and kill resilient bacteria and fungal spores. Examples include hydrogen peroxide and peracetic acid, known for their efficacy against spores while being compatible with cleanroom materials and equipment. Sporicides are applied through surface disinfection, wipes, and vapor phase methods, ensuring thorough coverage even in hard-to-reach areas where spores may reside. Due to their chemical properties, proper adherence to safety protocols is critical during sporicide use. This includes comprehensive training for personnel and the use of appropriate personal protective equipment to mitigate potential risks. Thank you for watching this introduction to this module. If you'd like to watch the remainder and get 25% off our Contamination Control Fundamental Program, head over to our website at pharmalliance.ie/training-programs and use code YT25OFF. Please do it now as spaces are limited and it's expiring soon. We'll see you on the next module.